Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0111, pertains to the intake air temperature, IAT, sensor circuit range/performance problem for the 2006 to 2011 Honda Civic models. This specific error indicates an issue with the readings from the IAT sensor, which is crucial in determining the temperature of the incoming air into the engine. An accurate measure is vital for optimal engine performance and fuel efficiency. The IAT sensor is generally located in or near the mass airflow (MAF) sensor assembly within the intake manifold area. It's essential to address issues arising from this DTC promptly, as it can lead to decreased engine performance and increased emissions. Accurate diagnostics is critical here, and it is advisable to start with an initial data collection phase by recording all freeze frame data before delving into specific tests or repairs. The intake air temperature IAT sensor is a vital component that measures the temperature of the air entering the engine. This sensor is typically found integrated with the mass airflow (MAF) sensor assembly in the intake manifold. The engine coolant temperature (ECT) sensors, which include ECT Sensor 1 and ECT Sensor 2, play a complementary role by gauging the temperature of the coolant to help regulate engine performance. Poor connections or loose terminals in this network can create a malfunction, leading to the P0111 code. It's crucial to understand that these sensors interact continuously with the Engine Control Module (ECM) or Powertrain Control Module (PCM) to optimize fuel injection and ignition timing. An effective diagnosis involves inspecting these components and their connections to ensure they function correctly and provide accurate readings. Several factors can contribute to the triggering of DTC P0111. First, poor connections or loose terminals at the IAT sensor, MAF sensor, or engine coolant temperature (ECT) sensors could lead to inaccurate readings. These connections must be examined thoroughly, as any dirt or corrosion can result in connection failure. Moreover, a faulty MAF or IAT sensor is another common culprit, either due to physical damage or internal malfunction. Additionally, issues within the Engine Control Module (ECM) or Powertrain Control Module (PCM) can create a cascade of problems, hindering the sensor's ability to communicate effectively. Each of these components must be considered during the diagnostics to pinpoint the exact nature of the malfunction and enable effective repairs. Drivers experiencing DTC P0111 may notice several symptoms that indicate a malfunctioning IAT sensor circuit. The most evident sign is the illuminated check engine light on the dashboard, which serves as a preliminary warning of engine-related issues. Additionally, the vehicle may exhibit poor engine performance, such as sluggish acceleration or stalling, as incorrect temperature readings can skew the fuel-air mixture. This imbalance often results in increased fuel consumption, leading not only to reduced efficiency, but also a potential increase in emissions. Pay close attention to these signs, as they can severely affect the vehicle's drivability and longevity if not addressed promptly. The first troubleshooting step for DTC P0111 is to check for poor connections or loose terminals at the engine coolant temperature (ECT) sensors and the mass airflow MAF sensor/IAT sensor. Poor connections can lead to erratic readings, so a thorough inspection is necessary. Look for damaged connectors, frayed wires, or any signs of corrosion. Verify that all terminals are seated correctly and firmly to avoid intermittent faults. If everything is secure and in good condition, you would proceed to the next step. However, if any issues are found, these need to be repaired before continuing. Properly securing these connections is essential for ensuring effective communication with the ECM or PCM which interprets the data for the engine's performance management. In the second step of troubleshooting, remove the mass airflow (MAF) sensor IAT sensor from its location. This operation is vital because it allows you to check the sensor's functionality without interference from ambient conditions. Once detached, allow the sensor to cool to the ambient temperature to ensure accurate testing. Recording the ambient temperature at this stage is essential, as it sets a reference point when comparing readings later in the diagnostic process. Uneven or false readings due to heat retention can lead to incorrect diagnoses and wasted time. Keeping track of the ambient temperature also aids in identifying temperature-related discrepancies in the sensor's performance. In Step 3, connect the MAF sensor/IAT sensor to its 5P connector, ensuring you do not reinstall it in its usual position just yet. This allows you to test the sensor while it is still accessible for further examination. Once connected, turn the ignition switch to the on position, but do not start the engine. This powers up the vehicle's electronics and allows the onboard diagnostic system to begin assessing the sensor's behavior. At this point, the sensor will communicate data back to the Engine Control Module, ECM, which is essential for the next steps in verifying whether the sensor is functioning as it should. Once the ignition is on, in Step 4, quickly access the data list using the Honda Diagnostic System, HDS, to note the value of the IAT sensor. This reading will provide a direct measure of the sensor's output under current conditions. Compare this value against the previously recorded ambient temperature to determine if there is a significant difference. If the IAT sensor reading differs by 5.4 degrees Fahrenheit or more from the ambient temperature, it would indicate a potential malfunction. Accurate comparison will help ascertain whether the sensor needs further inspection or if you can move to subsequent tests to verify its effectiveness. In troubleshooting Step 5, disconnect the MAF sensor/IAT sensor from its 5P connector once you have noted the IAT reading. Subsequently, utilize a heat gun to blow hot air onto the sensor for a few seconds. This simulation of incoming hot air is vital to check the sensor's responsiveness and functionality under warmth. It is crucial to avoid applying heat for too long, as excessive heat can damage the sensor and alter its operational characteristics. This brief test will allow you to observe how well the IAT sensor is able to respond to variations in temperature and establish if it is functioning properly or if there is an internal failure. In Step 6, reconnect the MAF sensor/IAT sensor to its 5P connector after performing the heating test. Note that you should not reinstall the sensor yet. With the sensor connected again, consult the Honda Diagnostic System, HDS, to check the IAT sensor readings. A functioning IAT sensor should exhibit a temperature change of 81 degrees Fahrenheit, or 45 degrees Celsius, or more relative to the earlier ambient temperature reading. If this change is observed, the system is likely functioning correctly at this moment. However, if it doesn't meet this threshold, further investigation will be necessary, as this could indicate intermittent failure of the sensor, thus requiring its replacement. Upon concluding the preceding checks in Step 7, turn the ignition switch to the lock position. If the prior test indicated a need, you would have to replace the MAF sensor, IAT sensor at this stage. The IAT sensor can fail over time due to factors like heat exposure, moisture, and wear. After replacing the sensor, it is essential to perform final connection checks, ensuring that all terminals are secure and properly positioned, as poor connectivity can lead to repeated error codes in the future. proper installation of the new sensor is crucial for restoring optimal performance and accuracy in engine management. Step 8 involves turning the ignition switch back to the on position post-sensor replacement. Here, the ECM or PCM, which stands for Engine Control Module or Powertrain Control Module, must be reset using the Honda Diagnostic System, HDS. This reset clears any stored trouble codes and allows for a fresh start for the sensors to operate correctly. After performing the reset, confirm that the procedure was successful by checking for any lingering codes. The HDS will assist in diagnosing any new or persisting issues, ensuring that the vehicle's computer systems are functioning optimally and ready for a test drive. Final repair verification entails checking for pending or confirmed DTCs with the Honda Diagnostic System, HDS, after you have performed the necessary repairs. Specifically, you should ensure that DTC P0111 is no longer indicated. If the code does reappear, it will require a return to earlier troubleshooting steps to check for poor connections or loose terminals at the MAF sensor IAT sensor, as well as at the ECM or PCM. Confirming that all systems are operational validates the completion of the diagnostic process and verifies that the sensor replacements and resets effectively restored the vehicle's performance. This concluding step is crucial to ensure no further issues persist, contributing to a reliable and safe driving experience. Preventive maintenance is key to avoiding future issues relating to the IAT sensor and its associated components. Regular inspections of the IAT and MAF sensors can catch potential problems before they escalate. Cleaning connections and ensuring all terminals are clear of dirt, rust, or corrosion will help maintain good electrical contact and prevent signal discrepancies. It is advisable also to monitor engine performance routinely. Any unusual signs, like a drop in fuel efficiency or a check engine light, may indicate early failures. Scheduling periodic checks and servicing can prolong the lifespan of these vital engine management components, ensuring your Honda Civic operates smoothly and efficiently over time. In conclusion, understanding and addressing Diagnostic Trouble Code P0111 is essential for proper engine performance in Honda Civic models from 2006 to 2011. The IAT sensor plays a critical role in maintaining fuel efficiency and optimizing engine performance. Therefore, immediate attention to issues arising from this code is pivotal. Thorough inspections of connections and terminals must not be overlooked, as they can often be the root of the problem. Regular maintenance and monitoring performance trends can help prevent similar issues in the future. Remember, successful diagnostics not only resolves the current error, but also enhances the reliability and longevity of the vehicle. Proper preventive care will go a long way in ensuring an enjoyable driving experience. Please like and subscribe to the channel. See you next time.